perfectly segue into the next panel, which is about how does this connect to the training that architects get both during their professional lives and when they are born as little proto-architects. And so over the next few minutes, we're going to explore that issue and talk about how the state of training today, and talk about what the challenges are to integrating these considerations into programs across the country. And so to get us kicked off, we have two leaders in architectural education. We have Robert Proul and Ralph Bennett, and they are going to give us we're going to start this panel off quite quickly, and we're going to have them give us a few remarks on their perspectives, and then we're going to go into some Q&A. And I believe that Ralph is going to start us off with a few words, and then we'll go from there. So please. Okay. Or actually,
Shall I use this one?
You can use that.
Can you hear me? Excellent. I'm here as the lowest common denominator. I know the least of any of you about what you're talking about here this morning. And I think that may have some value. I hope so. I've been working in issues of sustainability, as it's now called, since the early 1970s when working in Boston. I need a slide. This one. This one? This one. We experienced what is historically known as the Arab oil embargo, and we became excited about the idea of buildings which were energy conservative and had the ability to generate what's now called on-site renewable energy. We didn't call it that. We actually won a PA Design Award for Research in 1976 for a timeless little volume called Solar Heated Houses for New England and Other Temperate Climates. Of course, administrations changed, and the priorities that resulted in the subsidies that allowed those buildings to be built all disappeared. So I lost interest too, because I'm an architect and I became interested in housing, and that's what I did for a long time. And then I kept my eye on the emerging Green Building Council and its interests. And I was skeptical about some things, enthusiastic about many more. And I seized on my retirement as an ability, an occasion to become a lead AP, which I did. What a struggle it was. My wife remembers my cursing the monitor in the basement as I went through practice tests back in the days when you could become a lead AP by examination. Now you need to have experience, which you can buy at enormous cost, but basically my kids can't do that until they work in the field, which is great, but it's different now. But I'm an enthusiastic supporter of LEED for reasons that I will mention in a bit. And I want to address the issue of the incorporation of the information that you all are so compellingly and impressively interested in into the studio curriculum. What I'm showing behind me is a building that I designed in Boston in the early 1970s. It's a public skating rink. It's on the waterfront, hence the transparency at ground level. And materials are always, like all architects, really interesting to me. And we made some choices which at the time we thought were terrific. The translucent panels that you see beyond the curtain wall are made out of fiberglass. They have no U value whatsoever. But they were made by a boat builder in Providence, and we thought that was terrific because they were both structural and translucent, a property that I still value. The gray panels in the foreground are made out of, I dare not say it, asbestos cement. It was a fabulous material. It was used for countertops in chemistry labs. It even had its own trade journal called the Asbestos Cement Review, which I treasured. It was published in Germany. It was spare and elegant. I wanted to be published there, and this building was published in the Asbestos Cement Review. I don't need to tell you that that material is all gone. The building's been reskinned by other architects. But what it does is to highlight, for me, the issues that we face as people making complex structures. We've had some wonderful presentations. Ashley's questions, by the way, at the end of the last session were spot on. What do the professions look for? I'm also going to make the case that the professions are leading the academy in this field pretty dramatically, particularly as we saw by the RTKL tools that I really want to get my hands on. We as studio teachers believe that all information is best and most compellingly transmitted in the design studio. I've taught design studio off and on for 35 years. I got tired. I now teach 2 lecture courses on sustainability. I don't think I could stand 12 hours a week anymore. But it's where we in the Academy believe that information about buildings is best transmitted, including the information that you're talking about. I don't think we're right necessarily, but we believe it. Studio is about learning the many sources of form. That's really what it's about. And you know the number of distractions that are available to lead us to form. They have ranged from behavioral science to energy conservation, of course to history and all of its transformations, and of course it can be sustainability. And sustainability, one can argue, has its own style, which ironically enough includes a lot of glass, but it does anyway. But the idea of leading students, both through theory, through history, through science, in the studio, to the selection of appropriate forms is really what the studio is about. Now, we have experienced, I think, a profound revolution in the way we look at built form. And you see it emerging, re-emerging in building science. I'm also going to make the argument that there are some portions of the curriculum which need to be reestablished, and one of them is building science. The idea that architects would give up building science to building scientists is alarming to me, because in fact we ought to understand how the components of buildings go together, but we also know that in our growing awareness of the character of the building envelope, the interaction between the components and the addition of many more components is really our turf, but we don't know a lot about it. It leads to these kinds of weird contradictions. And what you see, this young lady sitting on the floor confidently because, as the ad says, the floor will be warm, but the balcony will not be. And of course, that possibility, one of the great hopes of modern architecture, the continuity from indoors to outdoors, is very, very much more difficult now. But it's aided by contrivances like the one that's circled, which give a cold break between indoors and outdoors. Or in another version, this idea of formal continuity between structural elements going between indoors and outdoors is also assisted by this device this firm thoughtfully provides. But of course, we're now in an age when even a 2x4 is a cold bridge, stunning to my generation. And I use for illustration here the character of this revolution. This is the NIST experimental house in Germantown, which a couple of students in my course have made reports on. And the contractor for this building is head of the GBC section of the National Capital Area chapter of the GBC, Dan Coffey, a very interesting fellow. But what you see here is really a surprising manifestation, and that is these ladders, which are located at the eaves and rakes of this house, are simply attachments. Stylistic elements which emerged naturally from the structure of the building as ornament have now become attachments to an envelope which is tightly wrapped and more or less impervious, depending upon where you live, and then made into a building which looks like a traditional building. Now, you could make fun of the engineers who invented this house. They have a good faith and extremely expensive approach to simulating real life in this building, but I think it's going to lead to good things because they're spending money looking at the various systems of the building, so it can't be bad, can it? In any case, it's there, and we're waiting for research results to come from it. So in order to acquaint myself with what you're talking about, I looked on the web for some EPDs. And I came across this one from a California brickmaker, having been set aside by a German EPD that was totally ununderstandable. There's this outfit, which is using its EPD, of course, to advertise the properties of its materials. And so it has graphic demonstration of the carbon footprint and embodied energy. And then it goes to a table like this, which is utterly indecipherable to me. But you are going to help us get to the point where we can understand what this means and how we can make intelligent choices. There is some helpful explanation at the end of the EPD here, but it's really the problem of making this information relevant and useful, not just to students in architecture, but I would suggest to architects as well. So I have some sources of confidence about what's happening, and I have some concerns. The confidence is that the young really do get this. My course is a kind of fifth column in the school. It's an elective course. In the 4 years I've been teaching it, I've gotten nearly 100 students through the LEED GA test. They spend half the semester doing that and the rest of the semester looking at other sustainability standards from around the world. We've looked at more than 75 now. And they're interesting. They're cultural statements, but that's a subject for another talk. The sustainability specialists, you can tell that the young get it because the sustainability specialists and coordinators in all but the biggest firms tend to be the very young. It's a tremendous job opportunity. There are even sustainability specialists who are not registered architects, but who are lead GAs and lead APs, and who have carried their concerns into the practices of which they're a part. Sustainability also motivates good design. That's why I think this is so valuable to the curriculum. Many of the traditional values in architecture, like light, view, proper orientation, are essential in LEED, and therefore LEED can be a vehicle for this. Perhaps more importantly, LEED encourages the integration, now the integrative design process, in which all the players in construction of a building sit down together. The best projects I've worked on in my professional career have worked that way. We try to make it happen in the little buildings that we do. It's not always so successful, but it's a very good habit of mind. The idea of the architect as a generalist who coordinates specializations of all kinds is deeply rooted in our tradition as a profession. And therefore, I'm confident that we can carry this on, that as architects we're capable of doing this. We just need to learn ways to A, identify specialists who are truly helpful to us, and B, absorb enough knowledge to be able to ask the right questions. Not necessarily have the answers, but to ask the right questions. In design studio, the point is to know how to use engineers, how to ask the right questions of the engineers to get you to the form you want to produce. So I think it's a source of enormous optimism. Now the challenges, as I said earlier, is that I think we need to have materials and methods coursework back. We don't have it in our curriculum, and I think we need it back. There needs to be a kind of a focus. The arrogance of studio critics, of course, is that we call them support courses, right? Well, there's clear from the issues that we're addressing today that it's more than support. There is intrinsic knowledge that architects need to understand in order to practice responsibility in the future. Secondly, I've had a terrible time getting energy modeling introduced into the design studio. You probably know that the University of Maryland invented the comprehensive studio, which I coordinated for a number of years there. I have enormous confidence in the ability of this format to teach. On the other hand, it's a limited vessel, and there are certain things it's difficult to do, and energy modeling seems to be one of them. But I think in design, we need to be doing energy modeling just the way we're doing physical modeling to understand our buildings better from the beginning. There's resistance to doing that. It is very clear that industry leads, not the academy. The presentations that just preceded this illustrate how forward-looking the industry is and how adept they are at producing tools that I, for one, am envious of. And there are many firms beyond the ones we saw which are producing information that's useful and important to us. It's too bad, but it's a fact. We have to deal with it. We have to provide students who can move into a milieu like that and be productive as soon as possible. But it seems clear, at least for the moment, that the industry is producing the kinds of ways of manipulating this information which are most useful to architects, and we had a great pair of demonstrations of that. But in the end, the choice of form has to govern what happens. These are very interesting enterprises that we're talking about, and materials among our ingredients. As Lance said, the ingredients are critical, and their characteristics, of course, are complicated, possibly toxic, but in the end, what we build buildings out of is really important. Now, it's easy with digital representation, which is so enticing, to get past the physical quality of materials and just concentrate on their visual properties. And I think that's an issue that we as designers need to face. But in the end, these materials are the basis of what we do. I appreciate what you are negotiating and discussing here. I'm deeply grateful that you are expressing concerns about the complexities of these issues that I saw when I looked at LEED version 4. And of course, it's no secret that the emergence of these concerns is what held up the adoption of version 4 for 2 years. So it's here. GBC continues to transform the industry. We're going to be transformed along with it. And I think the young are up to it. I just think we need to continue to develop tools that we can use to really understand life cycle analysis and understand what the true characteristics of buildings are. And I'm deeply appreciative to all of you for doing it. Thanks.
Yeah, all yours. All right. I think there's a slide, yeah. Hi, everybody. I'm Robert Proul. I teach architecture at Auburn University. I've been there since 2009. My focus there has been, well, essentially design studio and materials and methods of construction. And Auburn's actually a pretty good place to teach that. We have a really good reputation for that particular part of architectural education. The last issue of Design Intelligence, I think, rated us in the top 5. We're also rated in the top 5 in sustainability education, and this is certainly the overlap of those two things, and we teach very little of it, which worries me that we're actually rated that high, I guess, and managed not to really cover a lot of it. So I think that probably my value here is as an architectural educator, and maybe maybe offer a perspective on how we might move forward in educating future architects, or proto-architects, I think is what you called. You should trademark that word because I'll steal it. So a little bit about my background. I have a slightly different path to becoming a professor in architecture. I originally was trained as a civil engineer. I worked as an environmental engineer on environmental cleanup and reestablishing sort of ecosystems that have been polluted by various industries, we'll call it. I decided to go into civil engineering, oddly enough, because it had the least amount of chemistry in it. So everybody talking about how architects don't really know chemistry, I actually know more, and I still don't know enough. So I went to Auburn for undergrad as well, in architecture, for both engineering and architecture. And my first taste of sustainable material selection was at Rural Studio. I was a student there, and I studied under Sambo Mockbee. And we thought we were doing really great things, where we would use tires to build houses and things like that. And not that it's going to end up somewhere, so maybe in a house is the best place to put it. But that was kind of my lead into it. After graduating, I worked for a couple really renowned firms and on extremely large projects, call them architecture with a capital A probably. And some of those firms are thought of as firms that are environmentally conscious, although looking at some of the things that I see in industry today, we probably weren't enough. We didn't do enough in that sense. But this sort of unique background that I had of having an education in engineering, which was highly, highly technical, and then this other education in architecture, gives me the ability to constantly compare the two pedagogies. And I'm constantly asking myself as an architectural educator what it is that I should be teaching my students in in architecture. They don't let me teach students in engineering. I don't have enough chemistry. But Especially in the courses that I teach, materials and methods of construction, it is a technical class. And so there's a certain level of expectation that we release students out into the world, or proto-architects out into the world with, that we assume that they know, and it's based on the courses that I teach. Every student that comes through Auburn goes through my classes, and so you can blame me if you hire one and you don't like them, in a few years anyway. My real concern here, I guess, would be, or a few concerns that I have, would be exactly what it is that we should be teaching our students today. It's obviously evolving and changing, and it has been for a while. The way that we teach these classes is very different than the way that I took these classes as a student. And that's a good thing. It was very siloed at the time. It's becoming much more interdisciplinary between the topics that we teach, whether it's structural. I'm speaking specifically about building technology courses. At Auburn, we have quite a bit, a decent chunk of our curriculum set aside for these types of classes. But even with a fairly high rating by Design Intelligence, we're going through a really rigorous redesign of how we teach those classes right now. And certainly, I guess I'm here at the right time because this will most definitely become a part of our curriculum. But it was very siloed in that we had structures in one course. In fact, it was taught in a different school, building science. We had materials and methods taught by one teacher, or maybe two, and we had building environmental controls, which would be the sustainability courses taught by another professor. And the way that we approach it now, or we're looking to approach it in the future, is that these are going to be much more integrated with each other. That choices that you make that deal with sustainability or healthy building materials certainly affect other parts of the design of a building, like structures possibly, certainly aesthetics of a building, spaces in a building, the health of the people that are in the building as well. The other focus that I've had since I've been there has been in second-year design studios. So it's a very early portion of a student's education in architecture. We have quite a bit that we deal with when we teach those classes. We happen to teach materials and methods coincidentally with the studios that I teach, and I think that our department had probably set that up on purpose, that's where I've been sort of assigned to teach, because we can have a really good overlap between studio and a lot of these other courses. We have the second year faculty has a joke that in fall of second year we kind of own the students. Every second year faculty member teaches all of the students at the same time. That's very confusing the way I said it. What I mean is they take 4 classes, and all of those support classes, like Ralph mentioned, are taught by second year faculty. So we really kind of own their entire schedule, and it makes it a very fluid exchange of ideas between history and theory, materials and methods, environmental controls, and design studio. We have a really good situation where we can almost treat it as an experiment in a way to test the things that we teach in these support classes in studio. So in a lot of ways, studio becomes like a laboratory for the things that we're teaching in these other classes. And we actually shy away from the term support classes because of the sort of opinion that comes with that word about those classes, because it really does assign it a secondary nature, and we really feel that design studio is a way to really explore the ideas that they're learning in other classes. So as a second year design faculty member, I guess my other concern would be that obviously this is placing another constraint on students in their design process. That's not necessarily a bad thing. I actually preach to my students that constraints give you direction, and they answer questions for you that you don't have to really debate. I think that on some level, that's what must happen with healthy building materials as well. What I fear is that it will become simply selecting material out of a catalog and saying, oh, this is healthy, or this is safe, or safer. And it needs to be more than that. When I teach materials and methods and these in relation to design studio, I always try to make my projects very hands-on. They handle the materials, they work in the materials. We visit craftsmen that work in the materials, and then we also counter that with a field trip to an industry producer as well. So as an example, we make bricks, we fire bricks in our ceramics department kiln. They design the bricks themselves. They also go to a brick manufacturer in a nearby city and learn about the actual technical issues on a large scale. And what I don't want to, or what I hope doesn't happen with materials, especially healthy building materials, and the sort of removal that comes with a molecular understanding of what makes a healthier building material, is that it doesn't give the students a real tangible way to interact with the materials. So I'm constantly looking for that in the way that I teach. So essentially, that's what I do, and I hope that's why I'm here to talk with all of you today. So thank you for having me. It's a great event, so I appreciate it.
All right, so we're gonna wrap this up by having a bit of a dialogue on these themes that came up. And so, my job at this moment is to provoke, or inspire a few questions, and I hope you guys can prepare some of your own while I'm doing the provoking. So one of the challenges, just to kind of speak to some of the things you both brought up that kind of connect the day that we've had, is we have heard right from the get-go that we have a whole set of conceptual domains that are important, and I think that and I apologize not being able to remember if it's Lance or Russ that brought it up as saying, right from the top, we have issues of risk versus hazard, precautionary principles, the conceptual underpinnings of the whole reason we deal with chemicals in our building products. And then we run through a whole set of pragmatics, including EPDs and HBDs and all those categories, that alphabet soup of Tracy impact categories that were up there, all their weird and arbitrary numbers. So one of the questions I have is saying, that is as a body of knowledge, this morning we managed to just kind of scrape the surface of it, but in terms of how that fits, you have a packed architectural curriculum at the moment, you have limited degrees of freedom. Can you just kind of listen to your thinking about going, wow, where does that fit on the camel? I mean, is there room, or how do we make room, and how does it fit together?
Look at how do we all deal with the fire, as Amy Gardner says, the fire hose of information that's pointed at us every day. We have a generation coming along that's able to integrate more information than we ever were able to, particularly since I'm probably the senior person here, when I started doing this. So the capacity for dealing with information has increased enormously, and students' ability to deal with it has as well. What we're so grateful for is the taxonomy of building elements that's being produced precisely as a part of the sustainability effort. I think it's much easier to understand both the relative significance and the individual characteristics of information in the design process because of efforts like the ones we saw in the group before us. I think it's possible, I think we can do it, and I think we just have to do it.
I guess towards the question of where does it fit, or exactly how do we introduce it, my concern is that I agree, we do learn, or the students today learn a lot more, it seems like, in terms of topics. The one thing that I would say is, I don't know that they delve as deeply into the topics that we used to learn. Say in structures, I know for a fact that the structural education that we used to get, at least at Auburn, is a lot different than we do now. There were a lot more courses and things like that. Now, that doesn't mean that we necessarily delve as, we're shallower in it, but because it's changed the way that we actually think about structures now. But I don't think it's necessarily a problem to introduce the topics. It's really, the question becomes, how do we really get a fundamental understanding of it? A real, how do we make sure that the students absorb the topics on it? I think, at least at Auburn, to do it right, or to do it correctly, it would take what we're doing, what a lot of schools are doing, redesigning their building technology sequence. I think it can fit. Hopefully it's not really at the expense of other things. I always tell my students what I'm really teaching you is how to learn about materials. And this just becomes another facet of materials. So, because I certainly can't cover every single material to begin with. The book would be that thick, not that thick, right? And I think that environmental, sustainable, healthy issues about materials is another facet that would have to be introduced, I guess, in a way. In my opinion, there should probably be some specialization. I'll probably go back and propose a seminar for my department tomorrow. So.
Great.
Let me just say that I think your question leads to the leadership of the architectural profession. Barry and I were talking earlier about this issue of architecture who went through a phase of abdicating its role in the construction process out of fear of liability. All of this information leads to more specializations as well. And again, we as architects, I think, cannot absorb all this information. We need to be able to rely on people who do know it, ask the right questions of them, and make sure that they are directed to produce results which are responsible. That, it seems to me, is our role, not to know everything that everybody knows.
So actually, that's a good segue to, this is my last warm-up question, but Ralph, it might have been you on the phone the other day. We were talking about some of these things in advance, and you posed two, what stuck with me as challenging questions. One, I hope I'm crediting this correctly, that one, how complicated do we need this to be, and how simple can we make it? And that struck with me as an interesting challenge that I think goes to your point of the architect as a role as an integrator, and also in that role of saying what is the bare minimum of understanding that conductor of the orchestra needs to understand, yet at the same time, where does the technical depth run to? And I think that goes to a question that Ashley brought up earlier in her intro, basically saying, if we think that material scientists are that wealth of depth, we're probably mistaken. It's not in toxicology. It's actually not in the chemistry department. And it's not in the building science department. So we have a simultaneous problem of simplification, because I think you also used the point of saying the threshold of pain in terms of complexity has been reached. So if we can't handle much more complexity, we have to find a simpler path while not losing the actual rigor. And I've been struggling with that since you laid that out. And I wanted to share that with other folks, but also get you to elaborate on what do we do about that.
Sure, if we take a metaphor from another part of the profession, structural engineering, for example. Structural engineering now is taught most compellingly through graphic models which show structural behavior. I spent a whole summer teaching a course in steel detailing at Berkeley when I was a lot younger. It was the most tedious thing I ever did. And I didn't need to do it. But when Billington at Princeton started making computer models which showed the distortion of a continuous frame, a rigid frame, it was fabulously informative, right? So we have techniques now which make all kinds of phenomena visible to us in ways that we did not before, and I think we can understand. For example, the thermal performance of the building envelope is there with graphics that enable us to understand that holes in the exterior wall really do matter, right? We sort of abstracted about it, now we know how much they matter. So I think the way that you all and so many of our allied professions are making information available to us, we simply have to be clear about how students understand and get to it.
I would agree. I think the structural analogy is probably the easiest one to make, and that I talk about this with my students as well, that over the decades and the centuries, architects have really released a lot of responsibility to specialists and consultants and builders and things like that. And part of me wants to say, well, if it's not us that's why wouldn't architects be in charge of this? But the complexity level means that it's really us kind of steering the ship, and there's somebody else that's kind of plotting the course and doing all of the fine-grained analysis and work on it. The structural engineering is the perfect analogy for that. I think that some of it comes down to liability as well, that architects have to know it. It's easy for me as an architect to say, well, I'm going to hire a structural engineer for a 100,000 square foot museum project, right? It makes sense. They know more about it than me anyway. They have all the computer technology to handle that. But if I'm doing a much smaller project and I'm not necessarily going to be able to afford an engineer or need an engineer necessarily, right? Then I take on that liability in some way. The issue with healthy materials, I think, is more difficult in that we can still pick from all the materials no matter what the scale of the project or whatever the budget is. So I think that on some level we are going to be taking on, or we do take on, that liability regardless of what the project is. So we probably have to know it in some way or another. And painful complexity, I think is what the term was. It's there. I do think we need to simplify it down to sort of, it'd be best to get it down to one easy number, right? That's not our rating. It's not going to happen that way, but it'd be great if it actually did. I think we've heard about that today. There's a lot of gray area when it comes to healthy, even the term healthy stuff. Yeah.
It's all Larry Kilroy's job to get it down to one number. So, Russ, please, go.
It strikes me that as we try and if we think of the architectural education as preparing these students, these proto-architects, for learning once they get into practice, it seems to me that there's a value discussion that would be very important that I don't see as much in education from where I sit. I happen to, I took a course on the philosophy of engineering at University of Michigan. It was not in the architecture school, but getting introduced to Thomas Kuhn and Karl Popper and so forth. The suggestion that the answer you get is fundamentally a product of the attitude that you bring to the question is something that I think we could do a better job of educating our students.
I suspect you're right. I think that's where architectural theory lies. And I'm not sure that our theory curricula is strong enough to deal with those questions. I think you make an excellent point. I approach my sustainability courses by telling the students, particularly the one I'm teaching right now, which is Sustainability at the University of Maryland. It's taught to freshmen and sophomores. Some of them want to be architects, most of them are going to do something else. The issue I tell them ethically is that I'm not here to talk about the ethics of climate change. There are people who know more about that than I do. What I'm going to tell you about is how the regulatory environment is affecting the way we practice as if it were an issue. And I think there's an important distinction there. I don't want to be sitting there moralizing about this. I have my own feelings. I mean, I think CO2 is the overwhelming big problem. And I probably don't prevent myself from saying that from time to time. But the issue is they need to understand how their lives are being affected by regulations that are invented by people who don't watch Capitol Hill, watch local government. They're the ones who are dealing with these issues. We had an interesting meeting with a member of the county council in Montgomery County the other week, which he was going to propose using LEED silver as a standard for all buildings in Montgomery County, and he was dissuaded from doing that for all the usual reasons. But he said in the end, how do I know how carbon is affected by building codes? Because the county has a commitment to reduce emissions by 80% by 2050, and the curve is not looking like that. So he says, quite innocently, how do I know? And so that kind of simplification is really important, and it's all in the regulatory environment. We're all assuming that there's a crisis. You see what I mean? So if ethics and values are animated at different levels in different ways, theory curriculum, I think, is really important to do that. Sorry.
The term I like that you said is the attitude with which we approach a problem. And one thing that I've noticed, the difference between being a student at Auburn, however long ago it was, 15, 20 years ago, something like that, and being an educator there now, is that the students that I have approach these issues with great enthusiasm. That almost across the board, if the issue in any way of sustainability is brought up, they really actually try to take it on or incorporate it into their projects. This is in Design Studio, obviously. And I think on some level we could harness that. It's everywhere now. It's in the news all the time. They read about it all the time. And I think that as preparing them to be architectural students, that's a good thing because it really gives them a perspective that this is something that has to be taken on and solved in their lifetime, in their generation. So I think that I guess it's not heartwarming is the wrong word, but it's exciting to know that they are so enthusiastic about it, regardless of how they're being released out into the workplace. I think that the desire is there for them to understand it. It's our job to make sure that they do, and maybe not curtail that enthusiasm in any way. You know, with loading it down with details and things like that, I would worry might actually have ill effects.
I can't resist one little editorial comment. Russ, I think it brings up an interesting point. I mean, one of the most pernicious arguments against green building at the moment is the argument that basically green buildings are energy efficient buildings and everything else is a waste of resources. And we might look at places like Ohio where such an argument is being made to undergird. And I think that's a real challenge for architects and designers to be able to interface with a world where those kinds of arguments are common. And asking, what is the value of these considerations conceptually, philosophically, from, what is the precautionary principle as a role of design beyond just saving kilowatts or something like that. And so, anyway, I do think those are something that folks need to be prepared to engage on those issues. So sorry, just editorializing. And actually, I thought you were going to go there when you were talking about, Ralph had mentioned that, green building rating systems are an expression of values. And I think that's actually couldn't be more the case in the case of LEED, where the values are baked into what it is. So questions. John, why don't you go ahead?
Yeah. I think it's interesting that we're talking about, I think Lance's comment about not frightening the architects, I think is a key thing to remember as we go forward. But the idea of, what course do we add? How do we integrate this into the curriculum? But I think that, in a way, the answer was mentioned earlier in the definition of health. When you go to school, you're taught incidentally about health, safety, and welfare, and then after you take your licensing exam, that's you're through with that. But what if the idea was the World Health Organization definition of health, which has to do with physical and psychosocial health, which has to do with the pleasure of design, the people in the spaces, the effectiveness, the connections to history. Those all have at least the mental health connections that we are addressing directly here. And then by the time students get to the materials class, by the time they get to the structures class, the other classes, they're asking questions about what are the connections here to health that I've seen in the rest of design. Because that's the most interesting thing, the most challenging thing, I think you hit the nail on the head, is the idea of creating form. And that's a huge thing to get over in architecture school. But why not make this, instead of calling it sustainability, call everything health?
There's a question back there. Sure. I took that to be essentially a statement.
The thing is that you're proposing a separate course. You're saying that this is part of theory. These are other things.
It's not a separate course. You teach theory course. It's just boring because it's been conflated with history. Including morality, probably get more students. You think?
Well, the thing is that and you mentioned ethics as well. The interesting thing, the National Academy of Engineering is figuring out the only way to get engineers interested in sustainability, they said, was to teach it as ethics, as an ethical responsibility of the engineers. I don't see this in architecture either. I'm just suggesting that you've suggested that these are other aspects of education, as opposed to being central to them.
Well, it's interesting you would say that because I mentioned briefly that one of the great values I find in sustainability as a system is that it includes things that we've assumed over time. We assume behavioral sciences all the time in decisions we make about our predictions about the way people will use space. Oh man, no behavioral specialist is more expert than we are about predicting that, right? Well, not so much. Right, but also the ethics of building, we assume those things. The result, the LEED buildings are far more humane buildings. We always assumed that natural light is good and view is good, right? Well, there it is. There are credits for that in LEED. What could be better? I guess the question is to separate out what the ethical issues are versus what the pragmatic issues are of sustainability.
Chris, you were trying to get in.
Yeah, I think, again, it's sort of more of a statement than a question, but I think we need to consider the different levels of education too, because I think that the opportunities for ramping up sustainable education at more the sort of undergraduate level instantaneously are difficult for a number of reasons. And I think that as the tools that are developed become more user-friendly, I think it'll be easier to integrate them in what we call the sort of bread and butter architecture education. But I think that there are also graduate opportunities with post-professional opportunities like we do, we have, where it's possible to go into a lot of depth, have professionals, as we do at the moment, come back to school to enhance their knowledge, and then sort of spread the word within their practices. So I think I'm actually surprised that we don't have more graduate opportunities for architects to pursue their knowledge even further.
Just one comment on that. A few faculty at Auburn have talked about something. We don't actually have a graduate program in architecture. We have a professional bachelor's program. But one thing that's unique about Auburn is we have one of the oldest interior design programs within the School of Architecture, I believe in the country. I think it's over 100 years old now. It's changed over the years. It used to just be a straight interior design degree that you got, and now it's actually a second degree that you get coincidentally with a bachelor's of architecture. You can only get it if you complete a BArch. But a few faculty have talked about the idea of replicating this model as a way to specialize in other things other than just interior design or interior architecture. So we had a really strong foundation to stand on, and that this program was already established and very old, and they wanted to alter it. So it became the second degree, a double major, basically. But you could easily do that with, if you have the right faculty, with a lot of things, sustainability being one of them. Healthy building materials would certainly be some thread of course that's within that program. I think we've talked about it with others as well. Integrated design and construction is a master's program that we have, and we've kind of toyed with the idea of what would it be if it were a second degree that you could get as well. But I think you're right. The level of education is very important because it is a specialization in some ways, and even within the field of architecture, there are architects that are specialized in certain things as well.
So I think at this point I think we're out of time. So I'm going to ask the folks who haven't gotten their question in we're going to have actually time over lunch to have that conversation. So I want to thank Robert and Ralph for their time and their thoughts. A few things that are notable that are coming up, and I hope that if you're interested in these topics, you'll have a chance to go deeper. On Monday, April 14th, we're going to have Arlene Bloom come and talk to us about flame retardants and some of the things that she's doing next beyond flame retardants. We heard from our colleagues at EPA the importance of those issues. That's going to be held at a really awesome spot called the Kaiser Permanente Center for Total Health. If you have not seen their 60-foot-long, 10-feet-tall touchscreen, this is a chance to do that. After that, we're going to have John Knott come and talk to us. He's currently the executive director of the Health Product Declaration Collaborative, the folks who are driving the HPD forward as an idea, and that will be at USGBC on the 28th. So we'll be continuing this sequence of events to help us all become more familiar with these issues. These are two of the national and international leaders on the topic. So just as in a sense of closing from my part, I hope that what you guys, so I think the point of today was to have a fairly deep dive into both the technical underpinnings in terms of the regulatory regime, the information technologies, the material science considerations, learn a little bit about what some of the most advanced practitioners are doing, and then think a bit about how it affects the educational opportunities for architects. We've kind of covered those bases. In terms of level setting, I think one thing that's helpful for me is to think about this. If we go back 15 years with LEED and ask ourselves what we were trying to do with regard to the kind of apparatus for considering energy, that included integrative process, that included energy modeling, it included commissioning, renewables, green power, all these different dimensions of what we currently understand to be the regime of understanding energy, and the maturity that's taken a decade and a half or two building already on the experience of the 70s to get us to where we are today with all the challenges we continue to have in delivering energy. That is the course, that is the magnitude of the challenge that we have when dealing with health and healthy materials and so forth. We are embarking not just on a sprint where, 18 months from now, we're suddenly going to be like, oh yeah, we've got this done. We're embarking on a, many years long, decadal scale effort to add another pillar to the industry. So for me, it's helpful to think about this effort with a bit longer view and a bit of the history of what it took to get us where we are now with energy issues. So with that, I appreciate your thoughts. I appreciate you being here, and I'm going to turn over to Brad to close the morning. Thank you very much.
So I thought I would just sum up, from my perspective, a few things I heard. It's interesting to hear that the profession as the leader, that was a little stunning to me. Aren't we supposed to be the innovators in academia, the researchers, people who sit around and think all day and come up with stuff, and we don't have the pressures of sort of the economy or other issues to deal with? But that tells me, okay, I'm glad to know that, and we need to rise to that occasion. Maybe we have been stuck. The ivory tower has, two ways of looking at it, one as an isolation as well. I was really interested that Ashley commented about material scientists not having toxicology or health issues. Well, obviously we don't. We were never expected to. But I had a speaker, Bridget Williams, who's also in the EPA Design for Environment program, as a PhD chemist, and she had to go out of her way to take a course in toxicology as a trained chemist. And what was said to her was, why are you taking that course? This is not relevant to chemistry. But we know now that this all is very relevant to what we do. And I do think, when you think about the idea of architect as maestro, as integrator, we potentially have that sweet spot because we're not the scientist. We're not a pure artist. I mean, that to me is what architecture is. It's that link and integration between science and art, and that we do bring that human value and design quality. That's why we like architecture and we're not engineers. So we can bring in what is important here, it sounds like, is it's going to be a long road, it's going to be a hard road, there's a lot of technical details, but without the value orientation around a responsibility that if we do in fact spend 90% of our lives indoors, and I think that you have to get away also from this idea of it's about indoor air quality. What I think about, for example, in terms of waste issues is, what is all of this going to do to somebody somewhere 50 years from now? Everything we create is going to go somewhere. I think that's the other problem we're not addressing. The true idea of long-term sustainability, unless it's the cathedral of, and the pantheon and so on, everything has a life, and it's going to go somewhere, whether it's the emissions in creation or the emissions at end of life. And we need to start being that kind of evolved species. And I love the other statement, okay, we protect the environment, we don't kill ourselves at the same time, but it'll all come back to us, of course. And I think it was Lance's comment, or either Russell's, about the 10 to 20 year cycle. So we just got to be patient. I think that's really important and useful to us. So I think we have lunch outside, also in the back up here as well. So there's the same setting that you had for breakfast. And just a reminder, please feel free to walk out and see the student work that's being posted as we speak this afternoon. So I hope you can see what goes on here at the School of Architecture at Catholic. So again, thank you all very much for coming, and we're here, so we're very glad that you took the time today to come out and see us. Thanks.